Hello, my name is Ann, and I'm delighted to welcome you to our joint webinar hosted by global mold-based supplier DME and CAD/CAM specialist Cimatron. Today, we're lucky to have Mike Raymond, Director of Engineering, and Jeff Sarnecki, Regional Sales Director at DME, who will present some of the latest developments and new products within the DME portfolio. From Cimatron, we're also joined by Ralph Piccolo, Director of Sales, and Dan Branch, Technical Support Manager, who will highlight the efficiencies and benefits of using standard mold components within your 3D tool design. Please note this webinar is being recorded and a copy will be made available after the session. Throughout the presentations, we encourage you to post questions in the chat as we'll pause between each session to answer some of the questions. If you like what you see today and would like to be contacted by a DME or Cimatron representative, please be sure to hit the Contact Us button in the chat window and leave your details. So we have a lot of great things to see today. Let's get started. Mike, Jeff, over to you.
Thank you, Ann. Thank you, Cimatron team. DME has launched 4 new product solutions to address plate sequencing, undercuts, alignment, and venting. So getting into plate sequencing, multi-plate tools are very common within the injection molding world. They're used for part ejection, stripping gates and runners, in addition to also including multi-stage ejector applications. Sequencing these plates are very critical so that the molds operate correctly. And with that, DME has introduced the Easy Latch.
So in this application, we'll show you 2 different latch locks that we're using on this one mold. Notice that they're mounted on the outside of the tool. In the first application, we're going to run a 3-plate mold running off the A side to strip a runner. Here you can see the A and P knee plate being pulled back, creating the space to drop the runner. When it bottoms out on the housing, it pulls the stripper plate forward, removing the runner from the retainer pins. In this application, we're going to sequence the plates. The top plate has the lifters attached to it, which are being pushed forward to release the undercuts. The second sequencing plate has the ejector pins in it, which will push them off the part. So with that, let's take a better look inside these latches so we can see how they work. Notice the cam action that's red in here. We removed the springs so that there was no wear or breakage of this, which is very common. Here again, we attached the dual ejector system using the latch locks to sequence these plates. So with the latch locks, we offered 3 different series for different sizes of molds. We got 3 body sizes for each of the series and 5 latch bars for each of the lengths. The bodies themselves are made out of 50-140. The latch bars are H13, 46 to 48 Rockwell, along with the returner. Everything is nitrated and black oxide for smooth action. And with this, if there's a few questions.
Not seeing any in the chat right at the moment. Let's proceed to the next session.
So another common challenge within plastic parts are undercuts. And a very common way to address undercuts is using lifters. Lifters can be purchased as off-the-shelf items. They can be made as customs, or they can be made as a combination of both. Whether which ones you use, the challenge is breakage. So the DME team developed what we call the ACULINE lifter system, which implements a couple different features of auto-tuning or auto-alignment to prevent breakage as the lifters are installed, with just overall tolerance stack up and thermal expansion. And we'll address these issues within the next video.
So in this video, we're showing you two different lifter styles that we carry. We got the round lifter bar, and this one happens to be our coolant lifter rod. And we have a rectangle lifter bar. As you can see, we developed a different style of trunnion. We call it a shoe. The shoe has been wire EDM'd to accept the adapter ball, which is carbide, for a nice smooth trek. And I'd like to stop the video right about now. Okay, so I want to discuss this a little bit. Notice that we have a dovetail on our lifter bar itself. What we've done here is we've created this so that we can handle the thermal expansion. I mean, as you know, your mold grows, but your ejector plate isn't exposed to the same heat profile as the mold itself. So as your mold grows, it creates a binding action. And by able to put in this dovetail, that it will grow and it'll adjust by itself automatically. So that was the concept of using this dovetail on your adapter balls. And with that, we'll continue. As you can see, these adaptive balls automatically align to the angle that you need. Here we're showing you the carbide roller guides. They're there to protect the lifter bar and give it extra strength. In this portion of the animation, we're showing you our coolant lifter rod. What we're showing is a conformal cooling lifter head so that we can get coolant up there. They're easily assembled and installed in your tool, as you can see in this animation. So these are fully customizable for any lifter application. We can use them in both small and large molds. They're designed to stop breakage or binding. So I'd like to talk a little bit more about this. Okay, so as you can see on the left, it's the thermal expansion is the sample that we're showing you. I don't know how many times that you've had a lifter break in your experience, but if you get a part stuck, it has a tendency to bind or break that lifter. So in the upper right-hand corner is something that we like to discuss. This is our adapter ball. What we've done is we developed it so if you do get something stuck in your mold, that it will have a break point or a fuse in it so it doesn't destroy your lifter. You're just replacing the adapter ball itself. So it will take you a couple hours to replace this adapter ball compared to sometimes a week or 2 weeks to rebuild a complete lifter because there's no break point in it. And then the bottom picture is a picture of the shoe itself. The shoes are made from D2 and they're heat treated to 62 Rockwell. So these come in 5 different sizes: 1/4 to 1 inch in imperial, or 6 to 25 millimeter in metric. There's 2 different travel lengths of shoes in each series. The shoes are available in 0, 5, 10, and 15 degrees, and we can make special angles to fit any application. The lifter rods themselves, there's 5 different sizes in both imperial and metric. Available are bushings and snap rings for guidance of the round lifter rods. We carry a set of keeper keys to retain the lifter to the lifter rod itself, and a gasket that sits on top of the lifter rod if you're running coolant through that rod. The keeper keys themselves are made from 420 stainless, and they're heat treated to 48 to 52. Now the rectangle bars, the lifter bars, are H13 and they're 38 to 42 Rockwell. We carry 29 imperial sizes and 20 metric sizes of these rectangle bars. And again, we can make specials to fit any of your application. And with that, if there's any questions.
I see a couple of questions in the chat. This one is from Gerard Van der Meer. Are these parts now available in the Cimatron catalog?
Yes, these are available in the catalog now.
Great. There's another one from Gary Lewandowski. Could these lifters work in die cast tools very similar to injection molds under extreme heat, and how would they hold up?
That's a good question. Yes, they can work in die cast tooling. Everything has been heat treated to handle the extreme temperatures that go along with die cast. So they'll work just fine in that application.
Okay, let's proceed.
So the next area that the DME team addressed was mold alignment and the challenges that it presents. Thermal expansion, aged equipment, worn out leader pins, bushings, auxiliary equipment are different things that can affect how a mold opens and closes, especially in the final seconds as the cycle finishes and the mold closes. If you have standing cores, shutoffs, those can be very expensive if they start to wear out or crash. So with that, we've introduced the LT roller side locks to address that. And we'll explain some of that within this video.
So in this video, we're going to show you our new standard side locks. These locks were developed to fit into a standard footprint that's currently used throughout the mold industry. So the screw locations and the overall sizes are the same. Here, as you can see, you have a 30% longer lead-in, which is great for when you have crossover shutoff. So you're not busting your small cores going from cavity to core side or vice versa. And also there's a secondary lockup on it, so that you can maintain a tight seal on your locks themselves. They all come with carbide rollers to help guide these into place. Again, we wire EDM these so that they're a perfect fit. You don't have to worry about having a serialized lock, as they all fit within each other's. So what I'm trying to show you in this portion of the video is how an old worn machine or a heavy B side has a tendency to sag on when your mold opens. And these locks have been tested. and you can see that we can handle up to a 5-degree tip on it, straighten it up, and allows you to come in perfectly straight so you don't wear your shutoffs. And hopefully your mold will run as smooth as that. So to let everybody know, these locks are, the LT stands for the lifetime of your mold. We'll replace them if you wear them out, which we haven't been able to. So with that, I'd like to explain a few more things. The locks are available in 4 different sizes, from 1 inch, 1.5 inch, 2 and 3 inch. Of course, we got the carbide rollers, and we carry 3 different steel types. So our standard is D2. We carry DC53 for high heat applications, so you can run your molds at 750 degrees, and your locks will not anneal, move, or anything like the standard locks that are out there today. And what we did is we developed 440C stainless locks for the clean room application. To let everybody know that 440C is the type of steel that they use for bearings. So it's the toughest steel that I could find for the stainless steel locks. Again, they fit into the industrial standard footprint, and they can easily replace other locks. We wire the locks so that they're all interchangeable. And this is great for, like, if you have a shuttle application where you're going to have one male and multiple females, depending on how many stations that you have in your shuttle. And with that, if you have any questions.
I see some questions here. Andrew Pelosi is asking, how is the ball attached?
Okay, well, this has to go back to the lifter itself. And the ball is silver soldered onto the frame, and that frame is a D2. And every ball is tested with 1,100 pounds of side pressure to make sure that it's stable.
Okay. Daryl Hefeli is asking, is there a load rating chart to guide applications?
There is, and that would be on our website. And
Okay.
I believe it's in the catalog also.
Thank you. Krishna Bomasati is asking, is conformal cooling available in all sizes or in only certain ones?
The conformal cooling will start at the 3/8 diameter. So we'll have 3/8, half, 3/4, and 1 inch. And they'll be available at the end of January.
Okay, great. And one more, what is the cost between these lifters and standard unilifters?
The costs are relatively the same.
Okay.
I don't really go back and do price checks on our competition's components, but we price these accordingly, and we feel that they're a better system. And so they're priced according to that.
Sounds good. Okay, we're going to move ahead to the next session, but if your question wasn't answered, please join us in the expo where you can ask questions from the teams directly. And let's proceed.
So the next challenge that the DME team addressed was venting. Trapped gas can compromise part quality, causing short shots, burn marks, or messing with knit lines. And a real quick off-the-shelf solution is the vent pin, or I should say vented ejector pin. So if you get into a situation, maybe it's in a prototype or even a production situation where gassing is an issue, this can be a really quick solution. The pins in the larger diameters have 8 flats. As you step down to smaller diameters, they have 6. And as I mentioned, these are available off the shelf. They can be cut down and installed very quickly.
Okay. So as you can see, we offer multiple sizes in metric pins. The flats themselves are 0.038, which equals about 1.5 thousandths on our flats. And you can see in your up dimension the length of the flats on the pin itself. And then our next slide is our imperial offering. So as Jeff said, it's a good quick way of, if you have problems with gas buildup, it's a quick way to see how this will alleviate the problems by putting these vented ejector pins into your tool. And with that, is there any questions on our vent pins?
I see some more in the chat. Sam Viviano, do you plan on incorporating these into the top locks?
Okay, he's talking about the
roller locks, yeah.
The roller locks, yeah. Yes, we're actually working on those right now, Sam. We've done our prototypes, and we're going to be going into production levels in the next few months. So I'm planning roughly around March, April timeframe to bring these out.
Okay, sounds good. I want to thank you very much, Mike and Jeff. And just so you know, as I mentioned, the DME team will be available for questions after the webinar.